Hello, I'm Sriram, and today we're going to be going over AP Chem rates of reactions. So a rate is basically a measure of how fast something is changing. So rate, how fast is something changing? So back in math classes, you always had to use the equation distance equals rate times time, right? So like you went, I don't know, 5 miles in like 1 hour. Let's say you're going on a bike. So then you just solve for your rate, which is going to be 5 miles per hour. So that's basically a simple definition of a rate. We're going 5 miles per hour. So the same thing kind of applies to this unit in chemistry. We're going to be talking about how fast are reactants being converted to products. So how fast is this reaction going basically? So in chemical terms, the rate is basically change in substance. And by the way, these triangles, they're the Greek letter delta. They're basically used to say um, change. So this basically means change in substance over change in time. So this is either expressed as amount of reactant consumed by the reaction or amount of the product that is formed. So once again, it says how fast reactants are being converted to products. And knowing this allows us to design define some properties about rates of reactions. So let's say we have this reaction, um, aluminum with, I think, copper chloride. It's been a while. Becomes copper plus, I think that's aluminum chloride. So we want to see how fast copper is being formed. And let's say we are given a table. So time and then amount of copper. Let's do minute and then grams. So at time 0, there's no copper because the reaction hasn't started yet. So we just have solid aluminum and some copper chloride. Let's start the reaction. So now 2 minutes in, we have 4 grams. So the reaction is going 4 minutes. We actually have 8 grams now. So what is the rate of formation of copper? Well, you'll take your last value and your first value, and this is just the same thing as finding the slope. In fact, if we graph this data over here, as a quick sketch would actually just be something like this. A line, and this is time. This is amount of grams, 0, 4, 8, and then 2 and 4. And then the rate is basically the slope here. So how would you find the slope? Well, you would do rise over run. So you gained 8 grams in 4 minutes. So basically 8 minus 0. And you also, the time it took was 4 minus 0, 4 minutes. And don't forget your units, so grams per minute. So this is basically 2 grams per minute. So that's your rate of formation. Copper is being formed. So every minute on average, that's actually 2 more grams of copper being formed. So that's basically a reaction rate. So let's look at how we can relate one rate to another, because obviously it's not always just like one chemical that's being converted. Usually it can be more than one. For example, 2N2O5 becomes 4NO2 plus O2. This chemical is becoming both of this, both both of these chemicals, nitrous oxide, I think, and oxygen. Here we want to be able to like find a way to say that we know how fast N2O5 is decreasing in amount. We can also use it to find how fast NO2 and O2 are being increased. So one thing to remember about rates, and I feel like this could be the most confusing thing in the unit, is always know that a rate is positive. It's always expressed in as a positive number or zero, so non-negative. And think about it this way, when you solve distance equals rate times time, I don't think you would usually say the car is going at -5 miles per hour. Now, in physics, that's actually velocity. You solve for the velocity. But here, the rate is just speed. It doesn't have a sign. It's just positive or negative. Instead, here we just defined the rate as either formation or disappearance. So this would be a rate of disappearance because N2O5 is disappearing. However, NO2 is being formed, so the rate of formation. So you always want to think that whether you're there, whether the sign, whether this if that's a sign, whether you need add a negative to it to make it positive. And I know it sounds weird, but we'll go through this example. So we want to find the rate of disappearance of N2O5. So this is just a change in substance or concentration. Usually we just define the amount as concentration and then over time. Now we gotta be careful here because if we just say this is the rate, you would be wrong. Because remember, N2O5, we start off with, I don't know, like 5 grams of it, or like 5, the concentration is like 5, and then eventually we may end up at 0. So the change would be 0 minus 5, which is -5. And time is always positive. The reaction always, you can't say a reaction went in -5 seconds. That wouldn't make sense. So that means, let's say it took 1 second. It's a really fast reaction. So then you would say the rate is -5. But wait, you're saying the rate of disappearance is -5 moles per liters times time. That doesn't make sense, right? So what they actually do is we have to add a negative sign. So if you're finding the rate, add a negative sign to this fraction over here. So the rate of disappearance of this equation, so rate of disappearance, I'll abbreviate that, of N2O5 would be negative change in concentration over change in time. And then rate of formation, this is easier because you don't have to worry about the negative side. Because the reason is the fraction would just be change in NO2 concentration over change in time. We know NO2, it's just going to be forming because this is the direction of the reaction. NO2 is a product. There's going to be more of it over the reaction. So the change would be positive. So the rate's going to be positive anyways. We just want to make sure that the final rate we get is positive and we can mention them as disappearance or formation. This is I know maybe the AP exam there's a slight chance they will allow it as a negative rate, but with other formulas later in this unit, I just find it easier to I keep the rate positive and later notate in a problem whether it's disappearance or formation. Because there's other equations where you can relate one rate to another, and if you don't have your signs straight, you can easily make some mistakes. So rate of formation for O2 would be change in concentration of O2 or change in time, and this will be positive again because it's a product. So how can we relate these rates? Well, we can actually just use the coefficients here. So rate for a formation for NO2 is just going to be 4 times more than O2 because for every 1 mole of oxygen, that's going to be 4 moles of it. So we can similarly just use that same reasoning. So for so we can also say NO2 forms twice as fast as N2O5 disappears because 2 is here, 4 is here, this is just twice as fast. Finally, we can also say the rate of disappearance of N2O5 is going to be twice as fast as the formation of O2 because the coefficient here is just 1, this is 2. And later you're going to find a general formula where you can just relate each rate to each other, but for now this is basically the basics of it. So another quick reaction, the formation of water vapor, and all this is gas. So if you're given that H2, the rate of disappearance, or how fast H the concentration decreases per second, is equal to 0.15 moles per liters times second. So how would we find what rate O2 is decreasing at? Well, the rate of this is going to be twice as much as the rate of oxygen. So similarly, you would just divide by 2 to get it, because this must be twice as fast. So 0.15 over 2 would be 0.075 moles per liters times second. And then usually you can add the, it's standard to add the name of the chemical and its concentration, like mole O2. And you can also say decreasing or increasing. You can say decreasing here. It's just best to do it like this, as it doesn't confuse the grader. It won't confuse yourself either, because you can just look at it and say, oh, this O2 is a product. This is the rate, and rate must be positive. It helps when you do it like this. So what if O2, we were given O2 decreases, so the disappearance rate is 0.23 moles per liters times second. What rate is O2 decreasing at? Well, we know what rate is H2O increasing at? So when we find the rate this is increasing at. And note all rates are positive again. Need to stop saying that so much. 0.23 is here. This H2O is being formed twice as fast as oxygen, so we just need to multiply by 2. That's pretty easy. 0.46 moles per liters times second. H2O. And it's always nice to say increasing or decreasing. Or you can say formation. Disappearance. I don't know what I'm writing. Stuff like that. And then, yeah, this is basically first lesson how to basics over rate of reactions.